Having created the groups and showing you what the plots look like, the other thing that creating those groups allows us to do is to print out descriptions of the two groups that we created. So if I enter 134 minus, and I believe group 101 was the first group, and what that prints out is a complete printout of all the whole perimeter with all the curve data and everything else and all the points. So it's inverse around the whole perimeter. And if I now enter 102, which is the second section, we'll do likewise and show me the two complete printouts. So these are good to have for the record. And with that, we will begin some additional calculations. In this exercise, we're going to use the lot sizing routines to define the lots. And we're going to begin, as you can tell by the lot number here, we're going to begin right about here, working our way around the cul-de-sac with lots 1, 2, 3, 4, and 5, and then work our way along from there. So just so you have some idea of the geography of the subdivision we're working in as we go through these calculations. I come back to benchmark and enter 190 minus to get into the lot sizing routine, and I'm going to occupy point 37. Storage point is going to be 76. At this point, I am going to work my way around the known pieces of this lot with the inverse routine, and we're going to go to point 75. And we are going to inverse through a curve, which is the 68 minus routine. Radius point is 73, and the PT is 74. And we get our curve information. Continue on to point 67. And again, we're going to inverse through a curve. Now you'll notice in the examples in the book, you may see a 60 minus rather than 68 minus. It's because we added a command for inversing around curves that was universal, because we did have a problem with 60 minus meaning two things in two different areas of the program, and that was an inconsistency that was bothersome. So 68 minus is the fix for that. So anytime you're inversing anywhere through a curve, it's 68 minus, not 60 minus. So here we're going to go 65 is the radius point, and coming back out to 66, and we get the curve data again. Now we're going to develop the back line of our lot with the 192 minus command, and I'll digress here for a moment and give you a look at what we're doing by going to the mini manual, and we will work our way down to the lot sizing routines here, and we'll hide that, and you'll see that I'm working with this command right here, and you can juxtaposition this shaped lot to where we are in the cul-de-sac in the example we're doing. So given that, we'll go back here. 192 minus, the radius point of the cul, I believe, is 34. We're going to define a direction from point 37 toward point 6. We want an area of 12,500 square feet. We don't have any minimum width requirements. And with that, the program does its calculations, gives us the relative curve data for this particular lot, and an area of 12,500 square feet. We'll continue on now around the subdivision. We'll do lot number 2. We're going to occupy point 77 and start storing at 78. Again, the inverse process begins. I'm going to go to point 76, and that's as much as we know. the 192 minus command for radial lot sizing. Big radius of the cull is still 0.34. And again, we need to define a direction from 0.37 toward 0.6. And we need an area of 12,500 square feet and no minimum width at setback. And we come through and calculate that lot. And this is pretty much repeat as we go on through. I'm going to do one more here. 190 minus. Going to occupy 0.6. Storage at 0.80. Going to inverse to 0.79. To 0.78. And then we are going to get into radial lot sizing yet again. There's a lot of similarity in what we're doing here because, again, we're working our way around the cul-de-sac and defining direction from 0.6 toward 0.3. Same desired area. Oops. 12,500. No minimum width. And here we are. Lot 3 is now calculated. Now, when we do lot 4, this one has a little trick to it because we really kind of need to do it twice here. The first run will establish a 0.82 far enough around the cul-de-sac to give enough frontage. And then the radial lot line would extend way down toward the back line and give us way too big a lot. So the final, we still want a correct area, so we just let it kind of float the first time, and then we come back in and we'll use the sliding bearing routine to set a back line that works to give us the right size lot. So this next exercise will show the two-part pass that we need to establish this lot. And maybe I can right-click and pan and slide that baby up a little bit. First time we do this, this thing extends way out here and runs into this lot quite a bit. So what we're going to do is, once we establish the direction of this line here, we're just going to slide this line along this one and this one until we get in the size we want in here. That's the strategy we're going at. So back to the grind here, 190 minus, going to occupy 0.81, oops, excuse me, 81, and start storing at 82, going to inverse to 0.80, and do the radial lot sizing exercise again. Radius point of the big cull is still 34. We're going to define a direction from 81 toward 3. We're going to select an area of 13,000 square feet, which is pretty arbitrary here, but we want to make sure we have a width of 75 feet of frontage at a setback of 30 feet from the edge of pavement. This thing will grind itself out and give us, lo and behold, a 29,000 square foot lot, even though we only wanted a 13,000 square foot lot. So now we have to go through this exercise again to shrink that baby down, which we'll do by going into the routine again. 190 minus. We're going to occupy 0.81. And we'll start storing at 84. Yes, we'll do an 81 minus to go to 0.80 again. Just reestablishing what we know about the lot. 68 minus 0.34. point of tangency is 0.82. That's all our nifty little curve data for that chunk of curve. Now at this point, we're at 82. We use our sliding bearing 194 minus. And again, we'll ask for that area of 13,000 square feet. And now we'll define our directions away from everything. So for this line, the first line we're defining, we want to go from 0.81 towards 0.83. For our second line, we want to go from 0.82 towards 0.83. And for our third direction, we're talking about going from 3 towards 0.16. And at this point we've already established the point that gave us the width that we wanted on the cul-de-sac, so that's not an issue. So we can establish now our bearings and distances that around that area, and lo and behold, we have a lot that is indeed 13,000 square feet, which is what we're looking for. The rest of this exercise involves pretty much using the lot sizing routines to establish the rest of these lots. Now I can sit and do that, but you have the examples in the book to follow through. You've seen the exceptions for the every place you see a 60 minus, you should use a 68 minus, that kind of thing, but the examples are pretty consistent as far as following them through. When you're all done, you'll end up with all these lots, and I'll show you the files that I used to establish the final printout that gave me this whole subdivision. One thing I did need to establish was during all the time we were doing all this work, this whole file was being saved in the print buffer. So here you can see I've got 12 pages of printouts here that I can click through on a page-by-page basis. And you'll notice that up top, as I click through the pages, the heading remains there the whole time in terms of my company name and what job we're working on, etc., etc. So this is a pretty complete record of everything we've done. And I could have done a cut and paste to save this, but you know, here we are. We can do the same thing, print it out, and things are fine. So if I hit the print button right here, this will go to whatever I've established as being my Windows printer. And that really kind of covers the whole gamut of how that printing thing works. In this case, I'm just going to happily exit it. I'm back at my coordinate geometry menu. Here, I wanted to show you within the 130 minus command, which is the group editor, I've established all my lots. And clicking on any particular group number opens up the related lot. And again, you can see the point numbers, radius points were appropriate, and I've defined the descriptions of these things. These are, again, totally editable if I make mistakes or I get the wrong information in any one of these. And as long as they're all marked, whatever is toggled here as active will be aggregately sent out to that plot. So when you're looking at this, it's because all the lots that they were showing over here are indeed active. Okay. You notice I have a little button here. I can deactivate them all. And then if I just wanted to print one lot, I could just toggle the status. If I just wanted to plot lot 5, for example, I'd toggle the status of 5 to active. Now if I go through the 127 minus routine, the only thing that'll plot is this guy right here. The rest of these are inactive, and they won't be exported or sent out to the plotting routine, and they won't appear out there. So there's all kinds of cool little things you can do with this as you're working your way along. And that pretty much tells the whole story. This isn't everything that Benchmark does by any stretch of the imagination, but virtually every command that exists in Benchmark, there's an example for it within the big manual, the 488-page manual. So you can refer to some of the more obscure ones. You know, Benchmark is, because of its life, it accumulated more and more functions as its life was extended. So there's a lot of commands in there that are seldom used or seldom needed by people. The The old story is you use 10% of the functionality 90% of the time, and the other stuff, it's probably there, and you may need it from time to time, and if you do, it's great. Just go find it and use it. We tried to make it as complete as we possibly could. So here we'll exit this. We will enter 4 minus, and yeah, we'll save some changes, whatever we did, and be back at the main menu. And obviously, to kick benchmark out completely, I have merely to press the escape key to exit the benchmark menu and come back to my whatever screen is available, or in this case to my main screen. That concludes this presentation.